Well, good morning, everyone. My name is Eric Marsky, and we'll go ahead and get started here. What we're going to be covering today is actually we're going to continue on with our ongoing series we've put together on modernization of wireless systems. Anybody that's put a wireless system in, or quite honestly, anybody that is dealing with any kind of automation or control systems, are eventually going to come to the point to where they need to modernize their wireless network, or maybe even looking at putting in a wireless network for the first time. What this is going to do is this is going to allow us to help you get through that process. There's many changes that have come about. Those of you that are not familiar with the STEAM will give you kind of an overall introduction on who we are, what we have available, and overall what we're going to cover in this particular element is how do we modernize if the requirements we're looking to do an upgrade for is cybersecurity. What are the things that STEAM has put together that will allow you to better integrate the wireless network in if security? Maybe you've got an older wireless system that needs some update, that it doesn't meet the current cyber requirements that are put together by your IT system. Maybe you don't even have an IT network or platform laid out. And this will give you the opportunity to see what's available, things to compare to, and how STEAM can actually help you put this together. This is put together as a full series of things that we'll be doing throughout this year of ways that we can help you modernize this system. There's many things that we do. This is really all that we do day in and day out is wireless communications and wireless networks. So this is something that we've put together and hopefully will help you kind of expand that. And again, what we want to do is kind of introduce you to the concept of what does a STEAM actually provide? Well, first and foremost, those of you that are not familiar with who we are and what we do, we are actually a manufacturer of wireless hardware. We actually make about 10 different radios, different frequencies, different power inputs. Really what we try to do though is we try to look at it from an application basis. And to give you an overview of some of the major markets that we go into, water, wastewater, oil, gas, mining, even material handling, power, energy, agriculture, and as you see up there, the infrastructure and factory floor, all of these have some very common themes. The biggest things that you're going to see across them is either something's a very long distance away, something's in a mobile environment, or something that's just inaccessible by any other means. And since everybody's familiar, everybody has the ability now, or has the ability to go into a mobile environment, either through their cell phone, tablet, laptop, things like this. What this does is this is a transformation in the way that we are getting communication. And as you can see here, we've covered just about all the different industries, but wireless really has a good place into this. It solves many different things. What we want to do is we realize that there is an overall digital transformation from different points across the industry. Everything from the very basics, if we call it Industry 1.0, where we went to steam powered and made the original industrial revolution type changes. Then in Industry 2.0 was where we went into mass production, assembly line, put in electrical energy to replace the steam power. The revolution that came out after that, Industry 3.0, is where we automated systems. We were able to get communication. We're kind of now pushing towards the last piece of this, which is Industry 4.0, where devices themselves are actually telling us, the machines themselves are smart enough that they need to communicate all of their information back to a central location to give us the ability to actually act on this data. Okay, so what we're doing is we're actually now bringing all this into a network. So to make this completely connected network, there are some, we'll call them pillars, things that we need to do. First of all, we need to understand that what we're actually doing is we're moving information from the things themselves, the devices. We need to be able to act on this data So as you see on, say, the right-hand side of this, this is where we need to gather this data and do something with it in the analytics. So how do we move it? There's a couple pieces here. So the pillars we need is we need the things themselves. We need to be able to connect those things to a data source, okay? Once we have the data and storage of that information, now we can actually go in either through machine learning, visualization, automation itself, and actually then act upon this data. Now, overall, what you can see here is there's a lot of complicated pieces in here, things that moves. So what do we really need? What are our absolute must-haves when we're looking at having this connected network? Well, the first thing is it's, of course, having a reliable communication is going to be the key to this. And that's actually what we've covered in our first parts of our series. How do we make these basic connections? Most everything is now automating into an Ethernet-based arena. And because of that, the first few that we covered were really just the basics. What do we do as far as how we connect into Ethernet? And then the next one is because we need this persistent data acquisition and able to reliably get the communication back and forth. The next series we covered was really on how do we make it more reliable. So what we're going to do is we're going to help you through each of these must-haves when looking at completing this overall connected network. So as you see here, the next one we have listed is edge-to-edge cybersecurity. So that's where we're going to actually jump off today. If we continue on with the series, we'll see in here we need layer 2 and layer 3 connection types, network data on premises, so we can either handle it locally in a cloud. In a lot of cases, it's going to be a hybrid, where you're going to have both local data and stored in the cloud. We also have to have the ability to modify or scale these systems based upon what we're not only seeing today, but what we're going to be putting in for tomorrow. We need to be able to make sure that we're not building a system that only meets today's goals, because quite honestly, tomorrow we'll have already outgrown it. So we want to try to future-proof this as much as possible. And what we're needing to overcome more than anything else is we need to get rid of this silo concept of both the IT and the OT, and being able to connect all this data together, being able to provide it to the sources that are necessary in it. We want to create this frictionless operation between the two. So what we're going to concentrate is, we're going to kind of jump off here this morning, is we are now going to take a look at this one critical piece, this cybersecurity model. Now, as you can imagine, in a smaller conference like this, we're not going to be able to get into the absolute details of it, but I want to give you an overall sense of what's going on behind the scenes, what's available that Esteem will provide to you as far as security, and overall, maybe some concepts about cybersecurity that you never really thought of before. The first thing, the first critical piece of this is we need to understand that any security update or any update or modernization of a communication system, especially when looking at security, is no one single layer is ever going to solve all the problems. We cannot have one great encryption model, let's say, inside of the radio, and then everything that falls inside of that encryption model will be fine. It is a multiple layered security model, and it's been done this way for many, many years. So what I want to do is kind of show you some of the acronyms and things that are used when we're talking about wireless security. When you see some of these terms as far as AES encryption, and you really get into a multitude of different acronyms when we start getting into the security side of this. So I'll give you kind of a concept of what some of these terms actually meant, where we're kind of sitting at today, and what are some of the implementations we can do for it. The next thing we're going to take a look at is, we'll just call them additional security measures. Things that might not necessarily be considered. Things like being able to change the admin password, or disable some of these software features, or selecting what you configure or allow either the end customer or the customer themselves to be able to determine what they want to be able to do with the network. We want to be as flexible in the security model as the customer needs to be able to do for an application. You don't want to have to run into a simple point-to-point Ethernet bridge. You don't want to have to go into a multitude of different security mechanisms. It may not be necessary. So what we do is we give you the flexibility to set it up specifically for the application as necessary. Now, one thing I've done in many, many years of this is kind of laid out, and to be honest with you, we need to understand that the basics of this security model have been around for hundreds and hundreds of years. We can actually go back and take a look at history and just a simple thing as far as a medieval castle layout. Okay, as you see here, there was no single point. There was not just a single wall. There was not a single moat. You actually had to breach several different points of access to be able to get and take over a particular castle. Okay, and it's kind of interesting if we look at basically the modern diagram of how a security model is laid out. It's exactly the same. So this concept is nothing new. This concept of a multi-layered security model has been around for thousands of years because it works. So when we get even into a digital side of this, we need to understand that we're not going to be changing the rules of this. We will basically make that same multi-leveled security mechanism even inside of the wireless world. Now, of course, that continues into the overall communication or control system itself, but these are the things that we can do from the wireless side. The first thing is just take a look really at, we're going to unfortunately get buried in a few acronyms to begin with, okay? Everything that has to do with security, because it's such a long terminology, is an acronym of some type. The only ones that we're going to be concerning ourselves with is overall, if you see them, what does this actually mean? Well, the first thing is that there is this term called AES, okay? It stands for an advanced encryption standard, and it is a method of encryption. Now, the internet has been using this for all credit card transactions for many, many years now. I mean, well over 10 to 15 years. Kind of the standard as it sits today really is 128-bit AES. And we could go into the mathematics of it, and it would take a hard, in other words, trying all the available keys to it, it would take billions of years with billions of people to actually hard break that. It is actually, as it sits, essentially an unbreakable type standard. Well, things are progressing, okay? And because of that, some of the requirements for the next generation, we've actually gone one step above that. Instead of just doing 128-bit AES, we have the capability of actually going all the way up to 256. Now, as you can imagine, 128 being unbreakable, 256 is only going to make it that much more difficult. But we're really doing this not so much as seeing any security holes in the 128-bit, but preparing for the next generation of wireless standards. Because as it sits today, most wireless communication, when we're talking about Wi-Fi, because Wi-Fi really kind of sets the standards for wireless communication. Not that it is necessarily the best way of doing it, but because it is a standard, we all can agree that these are the way that our devices can talk to each other. So we're not running into this completely siloed, you're locked into a particular manufacturer to get your communication systems to work. We have now open standards to where we can all fit in there. Now, WPA is the Wi-Fi Protection Alliance, is really what the standard for it is. And that one that meets this 128-bit AES is what's called WPA2. Now, they already have, or are looking at the progressions of WPA3. And quite honestly, we've already kind of hedged our bets and put some of these features in, which we'll cover here in just a minute. The biggest thing to understand about it is that this is actually setting a model so that everybody is doing it the same way, where the process for connection, verification, disconnection on the system, that's really what these standards do. They set it up so that everybody performs the same task the same way. Within that, we also have the capability of doing different types or encryption models. You'll see something listed as a PSK. Most people are kind of familiar with this, even doing it on a cell phone. It actually stands for pre-shared key. And what you're really doing is it's a series of letters and numbers that start the encryption process. So if you then log into your phone, somebody tells you their password, it's admin 12345. Okay, well, that is actually a pre-shared key. Well, there's also a terminology called the enterprise model. which what it really does, it's kind of the level above pre-shared key to where you're putting this across an entire enterprise, so you don't have to give that key out, and then once that key changes, you've got to give that key to everybody that's actually physically connected to it. What this does is this uses outside sources. And a lot of ways it uses, that's like what the Steam ties into, a radius server that does nothing but do this password, username and password connections into the system. There are different ways of doing it. It may be a physical key, something that you plug in, USB. There are many different ways of doing that, but ultimately that's called the enterprise method for it. Now, there are a couple older terms here. They have actually really, we'll call them in a legacy side, but we also have different clients at different age intervals that have different, like we'll call generations of wireless hardware. So we have to support that. And we still do support the older or the first generation of WEPA and even the first generation of wireless privacy, which was called WEP. Now, remembering what all these standards are is really not as important as understanding that we have done very, very hard work to make sure that we keep ourselves in current compliance, and we will continue to do this. Because one thing that is a little bit unique with the Steam is we own our own IP. We build our own radios, we design our own radios, we do our own software. Because of that, we have the capability of being flexible and being able to change as necessary as these things change. So in addition to be able to meet all of these current standards, what are a couple of other things that we've provided into the security model that allow us then to, we'll just call them feature sides. The first one is actually kind of simple, to be honest with you. It is as simple as what we call a MAC filter. It is also one of the most difficult things to break. In other words, you have to physically designate which pieces of hardware you want to allow the network, be it either the Steam radios acting as a client or even Wi-Fi clients if you're running in a 2.4 or 5.8, the Wi-Fi type bands within the system. You have the ability to actually specifically allow a block of devices, divide by their MAC address. And again, getting into the acronyms, really what that stands for is every Ethernet device, Ethernet connected device in the world has a unique MAC address. So we're telling it what specific devices we want to allow within the network. So it's a very, very simple model in the fact that we can filter and change how these things talk to each other. But it is also very difficult because you have to have a physical, you have to physically have a device in your hand to be able to get what the MAC address is off of it. So it's a little bit simpler, but it is also one of the most difficult to break. The next one, which you see listed there, is something very simple to do, but no one ever thoroughly thinks about it. It's the ability to actually hide how the network responds to requests. People already use this features, which are called broadcast probes, and basically providing or transmitting what are SSIDs. When you open up your cell phone and you say, okay, what are the available Wi-Fi networks? What the cell phone is actually doing is it's actually sending out what's called a broadcast probe. It actually sends out to all the available, essentially open access points and says, give me your SSID. In other words, tell me who's out there. Well, we have the availability of turning that off. Even if you're running a Wi-Fi network, what you would have to do is you have to know the SSID of the network you're going into. So as you can imagine, being able to guess a network name, even outside of even looking at the security side of it, is incredibly difficult things to do. So just basically disabling the broadcast probes and hiding your SSID are very an incredible way of helping these things out. Now, as I mentioned to you before, we're kind of looking at future-proofing these radios. Another concept that is going to be in the next generation of Wi-Fi clients is what's called a protected management frame. Really what it does is that all traffic that is sent across a wireless network, including all of your management frames, who's on, what's happening within the network itself, currently the standard is that those are actually sent in clear text. Well, what this does is this protected management frame actually encrypts everything within the network. So there is no possibility of even seeing that. It's really not part of the standard as of today, but we're putting it in our radios to make sure that we have the capability of doing this for the next generation of radios. Now, outside of Wi-Fi networks and things like this, most everybody deals with our wireless system into what we'll call a bridge network. That's generally when you're connecting locations across the network. Well, we have the capability of not only providing this bridge link out to remote locations over long distances, we also can create these mesh networks. In other words, it's a self-healing, self-correcting network. And we actually had an entire system or a portion of, a presentation on the modernization on nothing but how this mesh technology works. And I would suggest if this is something that you're interested in, that you can go back and review that also. But one thing to understand about this is that the IEEE, who actually set the standard for these 802.11 or these Wi-Fi based networks, really never set how the base radios or the units that actually provide access to a client talk to each other. They say they can talk to it, and they give methods on how to get information passed between these base radios, but they never really said how to do it. Because of that, there are either you have to physically connect them together, or like what we've done is we give you the ability to actually connect those access points or those points of creating this overall wireless canopy. We allow you to connect to those remotely through the radio. So the radio is actually doing two functions. It's both functioning as a bridge. In other words, we're passing the Ethernet traffic between those two ports, and we're also functioning as the base, or what's called an access point, or AP, for mobile clients. Now, whether the network is actually sending the data as a bridge, whether we're configuring the radio as a router, or we're configuring it into a firewall mode, which we call the masquerade mode, the radios themselves can actually support any one of these type of connections to it. So it's an incredibly powerful device. What we then can do is we need to understand, because that is a proprietary type network, you have to have another steam radio with the correct configuration to even get in there. So it in itself is an incredibly great use of security just by utilizing that mode of operation. Now, we also then add to that the capability of even going up on these bridge links up to a 256-bit AES. So as you can imagine how secure those are, running that over a legacy, a proprietary type network is incredibly powerful. Now, one thing that we've also done, and we take kind of pride in doing so, is we give the availability of building these networks also based upon different encryption levels. So if you have older pieces of hardware to where we need to make our radios downward compatible, say to a previous generation, we're not going to abandon those. So we can actually support these various links at various different encryption levels, so that you're not ever abandoning an existing network to add into a new one. Or when you're looking at modernizing your network, we're not ever going to leave you holding the bag for a particular network. We work very hard on making sure that works. Now, how does this tie into a mesh network? Well, overall, we need to understand the basics of it. What is a mesh? Really what it is that as you see here kind of on the diagram of the screen, as you give these connections the alternate pathways and backup pathways, it kind of creates a spider web looking. That's really where the term came from. Ultimately, meshing is a buzzword. It's a wireless buzzword. But what it performs a self-healing. In other words, it will monitor all of these network connections. And if you give it redundant links, if it ever loses one of the links, it will automatically change over. So it's essentially what's called self-healing. Now, a Steam actually makes it a little bit simpler, that we're using a standard spanning tree protocol across there. We don't have anything proprietary, so anybody that's familiar with networks can understand how this all works. But overall, what this comes down to is, because it is self-healing, that's where we get the reliability of it. The network can actually take care of itself. So what are a couple other things that we can provide into this security model? Things that you might not necessarily consider. The first one is that we have the availability of actually changing the admin password. Now, in 2022, what we're going to be releasing is that all admin passwords will actually be randomized, so that when you receive a radio, there will be nothing similar between one radio and the next. You actually need, it's just a layer of security that will help bring this into kind of a modern requirements for it. The next thing is that we actually offer free software with our radios that help the configuration of it, where it sets the IP address. You can actually update the firmware. You can change some of the modes of operation. We also give you the ability to set how you want those tools to work. In other words, you can use them to monitor the network, but you can actually turn it off so that this software cannot make changes to the hardware within the network. It actually goes into a passive mode. You are completely in control of how you want the software to work within your overall network. It kind of utilizing that same methodology is that, quite honestly, it gives you the ability to disable remote access. One of the things that we can do to help you, get your network up and running is we can create a remote session to a computer and log into the radio no matter what's set to it. It's not something that we do, without setting up a remote session for it, but we do have that capability. If you do not want that as a feature or something that you want to be able to provide, you have the capability of turning this off. So adding all of these pieces together is creating that multiple layers of security that we were mentioning before. So what are some of the best practices we can get there? Okay. The first and most obvious one we need to look at is we need to use it. The security is available for you, but no lock that is not locked does absolutely no good whatsoever. So the first and the most thing to understand is all the radios will actually come to you with a configured for encryption. They will be set at a factory encryption level, and quite honestly, that in itself is better than nothing. But we recommend that you then modify these. You make changes to it. You want to enable client security access. We want to go and determine how deep we want to go with this. Do we disable the Wi-Fi access if not required, which we have the capability of doing? Even if you're running a radio that is running a bridge link at 2.4 or 5.8 that normally would have a Wi-Fi connection, you can actually turn that off. You can disable the SSID and broadcast probes within each and every radio, so that that's connecting to it via Wi-Fi. It's not even a capability, but you have the flexibility as a user to be able to make these decisions. The next thing we need to do is, if you utilize a static IP and you monitor this network, okay? In other words, we disable DHCP for mobile clients, remote stations, things like this. You have to have a valid IP to be able to enter this network. So it's a simple thing, but it will actually increase the level of security. Next thing to consider is looking at rotating security keys. Now, if you are something that you've got a much larger network, you may consider utilizing the enterprise mode, where you're basically rotating the keys as a whole cloth. If you don't do this, it's not a bad idea to set up a policy for key rotation on a fairly regular basis. You as a user can determine what is required to do this. What we also recommend taking a look at is defining someone within your network as the administrator. That's going to necessarily be IT-based person, but just a person responsible for maintaining the security and making sure that these changes that you put within the policies in, that they are maintaining and going forward with those policies. Okay? Just as kind of an overall introduction, everything that we talked about here kind of falls within our Horizon series. Okay? The Horizon series radio does many different things for us. First thing is it has this industrial mesh technology built into it. We can put it into a single device or multiple modes of operation within. One radio can actually serve as the base, a repeater, a remote, an access point, a bridge, a client. It's all software defined within the radio. We can set it up as both layer 2 and layer 3, as we said in our connected enterprise is one of the things that we want. And as we mentioned to you, we can do up to AES 256 on the encrypted connections. We're also set to do that on the client connections once the standard actually pushes that way. We've got it set up to where our tools can make very simple configuration to where you can actually lay out an entire network just on the screen, and you can draw the connections in between of who you want to talk to who. Another feature is that with every one of the radio has essentially what functions as kind of a SIM module. Really what it is, it's a memory module within the radio that you can move from one radio to the next and make that next radio appear as the radio you're replacing. So you don't necessarily have to have kind of advanced tools to be able to then modify this network. Okay, so all of these radios that we're talking about here kind of fall within this Horizon series, and we have them in multiple different frequencies: 900, 2.4, 5.8, and we even have a licensed 4.9 gigahertz band. Okay, now to continue on with this series, what we had done here was actually for cybersecurity. So we're going to continue on with this series into the next one is actually going to be modernization for mobility. How do we provide a reliable, connected client system out there? What we've tried to do is we've tried to simplify this, and we actually have a section within our website strictly for modernization. So if you go under the solutions, go under modernization, it will give you a whole page in there. The key thing to look for on there is kind of what we call the what. In other words, what are we actually doing? So if you now, after this security presentation is actually posted, what we'll be able to do is actually, if you roll over the cybersecurity, it will actually have in there where to actually get this presentation. So this is going to be a great resource as we keep building for it on how to modernize a wireless network. Because everybody is going to be in a situation to where they need to do this at one point or another. Even if you put in a wireless network today, you may be not modernizing it for 5 to 10 years, but it's still something that you need to do. So we highly recommend, if this is something that you're interested in, the next one we're going to be covering is mobility, and it'll be an 8 o'clock morning done on July 13th. Is going to be in the next Wednesday session that we're going to do. I do want to thank everybody for being here. If anybody's got any questions, I'll be happy to cover those. You can of course reach out to me at any time to my email address, which is Marske, M-A-R-S-K-E, @esteem.com. Give me a call at 509-735-9092. Or, of course, you can then do all of your own research really on modernization and the tools capable to you at our website, which you if you go to esteem.com, just put in /modernize, it'll get you right to that particular session. Doesn't look like anybody has any questions laid out for me, so must have done a pretty good job that way. But I do want to thank everybody for attending this session. And please, if you've got any questions, this is what we're here to do. We want you to understand that we are here to help you modernize your wireless network. Thank you very much, and you have a great day.